All right, we should be recording. So welcome everybody. Appreciate you joining us today. We've got a great webinar here about breaking barriers, sensible automation strategies. So we are recording the webinar, so we will be sending that out to everybody that is registered, and we'll also have it up on our webpage for others to come and look at. But we really want to talk about this topic when it comes to manufacturers and it comes to automation and understanding how we go about it. What kind of questions do we ask? That's what we're here to join today. So welcome everybody. Appreciate you coming. So this webinar is brought to you by the University of Idaho Extension. U of I Extension mission is to improve people's lives by engaging the university and our communities through that research-based education. So you can see on the map there, we have got offices in 42 of Idaho's 44 counties. Our other sponsor for today's webinar is TechHelp. TechHelp is Idaho Manufacturing Extension Partnership Center. So every state has an MEP center, and the mission of MEPs is just to help U.S. manufacturers succeed, help them with any of their pain points they might have. And so TechHelp's mission is to assist Idaho's businesses, growing their revenue, increasing productivity, performance, strengthening competitiveness. That's what we're trying to do with Idaho's manufacturer. We achieve this by offering services like these webinars, educational courses, and then consulting activities at your facilities. We want to make sure we meet your financial and operational objectives. We do have local offices in Boise area, in Twin Falls, in Idaho Falls, and then in the Coeur d'Alene Post Falls area. We also work with our state universities. You can see there, TechHelp is a partnership of all three universities, ISU, BSU, and U of I. And so if you have any questions, comments, concerns, anything that you'd like to chat about possibly, my contact information is there, and we'd be more than happy to help you. So those are our sponsors for today. Now let's talk about our speakers. We've got two great industry speakers with a wealth of knowledge in this kind of a topic to talk with you guys today. Jonathan Frank is with us and Chris Parker is with us, and we will let them introduce themselves. So let's get into our guest speakers. Jonathan, you want to talk about yourself here?
Certainly, I love talking about myself because I'm in business development. For the last 30 years, I have basically 3 acts to my career. Every 15 years, it's like act 1 of my play, act 2 of my play, and I'm in act 3 now. And so I was a working or practicing engineer for the first 1.5 acts before I was moved into project management and then business development. And in each act, I was working for companies that, for instance, Micron, when they had their production of computers going, and then later on, Act 2 was in medical and aerospace device manufacture, development and manufacture. And now I decided for Act 3, I'd go back to my roots as a manufacturing engineer and get back into control systems and some of that type of thing. So yeah, I'm very grateful to be here and have the opportunity to speak into this this very important topic for those who are looking to get started in automation. And with that, I'll turn it over to Chris.
Thanks, John.
Jonathan.
All right, so I'm Chris Parker, and I represent Astra. So we're a multi-discipline engineering firm located in Twin Falls, and so my background, so I was a plant engineer. I say over 15. I'm almost ready to start saying 20 years, but about 15 years of plant operations experience. So my background is very much, I'm a plant guy. So I was in controls and automation and process engineering, project engineering, and all the way up into executive engineering leadership out in industry before starting the company 5 years ago. And a lot of my background is in food manufacturing and processing, particularly in dairy. But I have kind of it's similar to John. I have kind of a varied background too, where I even have some mining experience. So early in my career, I spent time in mining, and now with Astra, we do work with mining as well. So a lot of experience in different process industries and natural resources, and of course food. And so I spent several of those years as a controls engineer, so I have a pretty strong background in automation, and I've also managed a lot of automation projects. I've seen both sides of automation, and what can go well, and what can not go so well. And so I'm happy to share those things today.
Great. Thanks, Chris. Appreciate your time. Appreciate your time, Jonathan. So we'll get right into the content, and I believe Jonathan's going to start us out today to tell us about where we're going with this webinar.
Yeah, so where we're going, the map for this webinar is first in identifying the right resources and partners for automation projects. This is assuming that you have something in mind and what you want to, as far as what you want to improve in your process, or even the solutions you have in mind. And it's about building your team. So we'll have a slide on that at least, and then overcoming barriers is the next one to change management and employee adoption of automation. And that's really about touching on the project management aspects and communication aspects, and the people, which is the most important aspect. And I often say to folks that, you know, it'd be hard on the problem, not on the people, you know. So without the people, it's difficult to implement any change in an organization. And next is developing the business case, and developing the business case and evaluating return on investment of automation projects. Chris has some very good things to say along these lines. You know, from the supply chain to customers, it's important to have that business case prepared. Finally, addressing common automation myths and misconceptions. Speak on that, and then implementing gradual scalable automation strategies for small businesses who perhaps do not have the funding or time, resources in general to do, you know, basically implement what they'd love to see in place at the end of things. We'll talk about a gradual scalable automation plan, and then standardization and developing a plan to address obsolescence in automation systems. So there's a lot of content, so we respectfully request that the questions, perhaps wait on the questions until the end of and when we'll open up a time to answer questions. Thank you. I believe Chris is starting us off on the next one.
Yep. All right. So, you know, there may be those in attendance who have longstanding relationships with integrators or automation suppliers of different kinds. I use the term integrator pretty loosely, just anyone who's providing automation services. But some of the folks are going to have pretty good long-standing relationships with integrators and suppliers. Some are maybe looking to find the right support for their projects, and so we've got a couple of pointers to share. So this is maybe self-evident, but referrals is going to be your best source of partners for projects. So it's a good idea to reach out to other folks in your industry in the area, or perhaps depending on the industry, maybe just in the industry at large, to see who has done well in your processes in terms of integration. However, if you're in a niche industry, or maybe you don't, you're unable to glean referrals from others, there's other ways to find integrators. So for instance, Rockwell Automation, who's linked with Alan Bradley, a pretty big name, they have an integrator list on their website that you can go to see who is partnered with Rockwell. There's the barrier to entry to that list is somewhat high, and so the list is narrowed down to just those who, well, spend enough money with Rockwell and Alan Bradley to get on it. So it's not all inclusive, but it's definitely a good place to start. Also, inductive automation, other OEMs such as Fanuc, they also have listings of partners, preferred partners, qualified partners. For instance, Inductive Automation has certain training requirements that need to be met to be listed on their website. So I consider it to be a very good source of potential partners. But either way, no matter how you go about it, if you're looking to engage a resource, an integrator that's unknown to you, I would definitely recommend checking references. If ask for a few, and remember that just like anyone, even an applicant to a job at your company, they're going to list the people who's going to give them the best referral, right? And so remember to take those referrals with a grain of salt, and definitely ask real questions. Like for instance, ask, hey, what were some things that were challenging with this particular integrator or this particular supplier? What are some things that you have to pay attention to when you're working with them? Because there's going to be something. Nobody's perfect. And so if someone doesn't have any sort of constructive feedback at all, you might question if you've dug deep enough or asked the right questions. Once you've engaged a resource or perhaps part of this the interview process, you really want to pay attention to their approach. Approach is key, and I know Jonathan had strong opinions about this as well. But an integrator really should be focused on you and your needs. Integrators and just engineers in general, we're nerds. We tend to be a bit self-centered in our processes, and so it's important. It's important to see that they're willing to step outside themselves and really look to what you're needing and tailor their approach and their processes to you, and not only stick to the processes that they know and what they're familiar with, because that can be challenging as you navigate a project to get them out of those things that they know well. But either way, and this is true of any business dealing, any agreement of any kind in the world of business or projects or services, is be sure to maintain accountability. And this is something that I think that's easiest to slip. In fact, when you know an integrator really well, it's like, oh, hey, these guys, like, they'll treat me well. Like, we don't have to sign a purchase agreement or service agreement or something like that. And I would definitely advise against that, because you just never know. And so always, and not only that, but maintaining that good relationship is super important. And the best way to maintain a relationship is to have clear communications and clear expectations, right? So if you're maybe new to managing automation projects, or maybe a new company, or maybe a new manager, I definitely recommend consulting a business attorney. It's not scary or anything like that, but just have someone who deals with contracts and business law regularly. Take a look at an integrator's proposal, or take a look at the service agreement, just to make sure that you're well protected as you navigate a project. Don,
Definitely.
did you have anything to add?
Totally agree. So what I have to add to that, Chris, is to add to that is, often, especially if you're talking about agencies at the state or local, state, and federal level, there's an outfit will have a statement of qualifications already prepared. So that's something that you can ask for right away and see their references and what they propose for for solutions to their customers, and where they're qualified, where their strengths are. They often list what type of products that they'd like to work with. And that's one way to kind of match up with prospective engineers and integrators. At Advanced Control Systems, we deal a lot with the wastewater treatment plants for these for different levels of government, municipal, for instance. And we often get referrals from, like, the ditch riders, who are part of organizations. They're almost philanthropies, as far as they get paid, but it's by an organization that's taking their funding from those who are donating, usually the cities and so forth, to send their operators to classes through this organization. And they also offer training, such as the IRWA, the Idaho Rural Water Association, will offer training to the operators in these water plants and wastewater treatment plants. So there's a lot of different places to get the referrals. I also wanted to add that, building the team needs to start also internally with your business, the different levels of business. So you have marketing and operations and finance, and you'll need to get those folks involved from the very beginning. Also from supply chain and your customers, get them on board as soon as you can, because you want to test and I guess fail forward quickly, right? With the potential automation project. And so, it really begins with those, who design, back to the engineering firms like Chris's, those who design these automation projects so that all the electricians, the programmers, and the management team can look at a set of plans and specs and get on the same page is critical to get on board from the start. So that's part of your team. So just wanted to stress that building the team, definitely go to your suppliers, the potential integrators of Rockwell, Inductive Automation, Fanuc, and so forth, but also look inside.
That's good feedback, John. Because if a firm has a SAM account set up and has a competency statement or is perhaps set up through like the ISN World Program, the barrier to entry to that, you have to have some experience. You have to have certain insurance coverage. You have to have certain training programs put together. And so if an outfit is set up in those systems, they're generally going to be pretty well qualified.
Yep. Yeah, so on this next one, I kind of started early with the get the stakeholders involved in building your team on the last slide, but it's not just the management team. Operators are probably the best source of information that's real to life. And it's good to have different parties involved in that, such as Tech Help. I think that they're planning on some, potential, and they already have some offerings where they can be kind of the third disinterested party, more or less, where go in and talk to the operators, look at the process and the proposed, what the problems are and what the proposed solutions are, and give all levels of the business, again, finance, marketing, and operations, the management level, the same, kind of feedback at the same time. Oftentimes, in my experience, operators, they're a little, cautious about sharing a lot of information in their circle of influence, you might say, within their company. So it's good to have that resource available from Tech Help. Also, you want, like I said earlier, communicate early and often, and it helps to have communications methods in place. And a lot of larger or mid-sized companies do. They have a project management kind of mode of operation. It could be the PMI method or other, it could be, PMI stands for Project Management Institute. It's just a project management method to get a project launched, build the scope of work and so forth. But you can also, if you're a smaller company that doesn't have something in place quite yet like that, and don't have the time and resources to learn and implement it, just getting people on the same email string from the get-go and keeping them on it as you go along, the whole team, is a helpful method. There's been more than one case where I've seen communications kind of fall off because there's just people get left out of the email reply. It's very important to keep everyone in the loop as you go along and address the concerns, as that loop of teammates, or, even if it's a skunk works, project where people are just, they just want to be, they come aboard because they think that you have something good to contribute there. They may have concerns as you go along and address every single concern from the operators to on up through every level of the business. Don't dismiss any of them. Make sure they're resolved, or at least, I wouldn't say it's great to manage a project, for instance, in automation by consensus, because there's always going to be someone who knows and maybe at a different level of authority that needs to kind of just make the decision. But it's good to make sure that all the concerns are on the table, right? Also, we want to make sure that that is clear, the change management process is clear. So right from the get-go, kind of lay out what the plan is, for everybody, so that they understand that this isn't something that's going to suddenly appear on their, in front of them on the production floor. Kind of put their mind at ease, right? Show them the path right up front. So one example of that in my history is with a company that was building computers, and there's a sea of computers that would be automated, that had automation to download the software and to burn in the RAM, memory, and so forth. And it was a manual process where an operator would go up and down the rows 3 levels high and plug in every computer to see what was going on. And often it was up to them to interpret what was going on, and they didn't necessarily have all the experience of someone who deals with the software of a computer. So there was a lot of interpretation going on. And one thing we did was to create a skunkworks project. And as far as team members, I enlisted folks from legal, that because the company at the time was giving bonuses for patents and so forth, and I involved all levels of management, and we basically came up with a solution that was basically a little LED indicator that plugged into the parallel port on the older computer boxes, and we put it together in such a way that it was inexpensive because we had everyone involved, and we knew where we stood on the budget and so forth. And it moved along quicker than it would otherwise, to have everybody involved in that process. All right, I'm good to go for the next slide, sir.
Well, a couple things just to add to that is I think just to expand on something you said there, John.
Sure.
When you're getting all of the folks together on a team and all the stakeholders and looking to get everyone's concerns out, it's important to get the consensus, but also to upfront, because it's way easier to set the expectation upfront than it is later on, that not every problem is going to be solved. Because you don't want to lead people to think, oh yeah, we're going to fix everything with this project, and then the scope creeps and creeps and creeps, and next thing it goes to management review and the budget's way too big and it just doesn't fly. And so it's a good idea just to make sure, like, hey, we're collecting these concerns and these issues, but we may not be able to address all of them. I think that's a very important point. And because like Jonathan mentioned, the number of times that we've gone into facilities and having just been briefed by some management team about what was going on in the plant and what the needs were, so only to find that the operators had a completely 180-degree different view of what was happening. I mean, I would say it's the majority.
Right.
And so it's something that all managers and business owners and anyone that's a stakeholder needs to really put some thought into that, because it says something about our communications. And then in this instance, it's just reinforcement that it is a very big deal that you've got to pull those operators into the process, because they know a lot of things that you probably don't.
I agree completely.
All right. Developing the business case. So this one is, I would say, just as important as engaging the entire team. It's something that in the world of business and manufacturing is critical and often overlooked. A lot of projects can be, for a lack of a better term, they could be sort of pet projects or political issues or something like that, and not actually have a real concrete business case. And so it's important to really take the time to make sure that you actually understand what it is that you're looking to accomplish and why is it that you need to accomplish it. A good example is, before I jump into this, is we recently supported a project at an agricultural operation where they were looking at investing millions of dollars into a plant expansion because they were convinced that they needed to do that to increase their capacity. And what we found through digging and applying some root cause analysis tools, that Well, actually, for a whole lot less money, they could actually achieve the goals that they needed to just with some basic process improvements and some application of some fairly low cost automation solutions. And so that's why it's so important to dig in. So if you're familiar, and if you're not, I would definitely recommend reaching out to perhaps Tech Help to get some support with root cause analysis. Using tools such as the 5 whys or any of these lean manufacturing, root cause, TPM sort of tools to really dig down into things is the first step. You've got to understand what is the real issue here and what is the real problem. What are we trying to solve? Um, and if you don't have, let's say you don't have all the information to gather that, that could be a part of the process is what do we do to get that information? And it doesn't necessarily have to be very sophisticated or costly. It doesn't mean that, okay, before we can do anything, we've got to implement a SCADA software system for $50,000 or $100,000. It could just be a log sheet. It just could be an operator filling something out regularly with observations or record certain information periodically, so you have the information that you need to make good decisions. So just try to keep it simple. And so once you've defined what it is that you are looking to accomplish and what the root cause of this, whatever this concern is, it's important to then determine, okay, using that data, how big of an issue is this really? Is this an issue of waste? Is it limited, capacity? Is it a safety issue? And assign some value to that. Start there. Say, okay, this particular problem is costing us, say, $10,000 a year, and from there, then say, okay, as a business, or in our capital project approval process, we're expecting some certain, RIR or simple return or something like that. A simple payback, a 2-year payback, 3-year payback, whatever it is, however your company defines that, then set the size of your budget to that and say, okay, so we know that we need a 2-year payback on projects. It's a $10,000 issue. We can spend $20,000 to fix this. And then use that number to then start sizing a project and start developing a scope of work. By starting there, you can eliminate a lot of time wasted in backtracking and redoing the scope of work and the nature of the proposal. And even maybe, at the risk of upsetting some people, because you may say, okay, we're going to do all this really cool automation stuff, and then you realize that, okay, now the reality of it is okay, the project has to be just this big, not this big. And so it's just important to have a really thorough and consistent process, just to make sure that you're efficient and you've got a good presentation to the management team or to the bank or whoever it is that's going to approve the project. Because the better equipped you are, the more clear you are in your problem statement, the better time you're going to have getting the project approved, whoever it is that's approving the project. But remember, and this is kind of a reiteration of what we talked about a few moments ago, is, as you're developing the solution and as you're adjusting the solution to the budget, to the return that you need to achieve to have traction with the project, is to make sure that you've got your nice to haves and your design criteria clearly identified. And remember to sort of preface all of that by saying, hey, we can't fix the entire plant in this one project, or we can't do it all. We have to size this in such a way that we can get this thing done because this is what we need to do. But if the value is really high, maybe we can throw on some kind of nice to haves alongside it, but let's focus on the core issue and addressing that and then go from there, if that makes sense. Jonathan, any follow-up comments?
Yes, very good details there. And I think that it can be overwhelming, it's, especially if it's a small business, that's up to 15 people, or a medium business that could be, in the low hundreds to, larger enterprises. All this to do for, perhaps solving a little process bottleneck problem can seem overwhelming. And so I want to touch on the fact that Tech Help is there even to develop the business case, from building the team, from also for you know, overcoming barriers of change with respect to people and, you know, what we touched on the last slide, and here on the business case, even they can assist. And, you know, when I was a manufacturing engineer, I would go in and I would do process flow diagrams, and I would do work sampling studies, and I'd get kind of all that data pulled together. But that took, you know, I was a full-time manufacturing engineer doing this. You can pull in resources to kind of address the complexities and make it a little bit more simple for, you know, the one or two folks who are really championing the project at the facility. And, you know, I start with dull, you know, you may have heard of the 4 Ds, the dull, dirty, dangerous, and dear. When I walk into a place, I see a lot of different processes in my work. For instance, a precious metals and minerals mining outfit recently. We walked in and it looked pretty cut and dried. They did have a laundry list of automation projects to do that, you know, included everything from people having to lift heavy ingots around, and, you know, so there's safety concerns and whatnot. And that's one thing to consider too, is the safety. Often safety and security come kind of last to mind sometimes for those who are looking at solutions, but it's ought to be brought right up to the top. But going into this new facility and talking to the team, our first perceptions was that they knew what the business case was, they knew what their timing was, they knew what their budget was. And after many visits, we learned that, in fact, they knew that they could save up to 8 operators in the packaging area. They just wanted to duplicate a robotic arm cell, but that wasn't really the solution per se. They did have trouble. They could see that they couldn't get operators in their area that were willing to do the work. So there was some savings there. But it turned out, you know, many visits later, that there was another site in another state even who actually had players, you know, that should have been part of the initial team that had not been involved in the discussion, and who had already been prototyping another robotic cell. So I'm kind of falling on my sword here, because that project kind of devolved, and they're regrouping now to come back with what they need to do with respect to everything we've talked to so far, you know, especially developing the business case. So definitely agree with what Chris had to say there.
Well, and that's a good example of the sort of approach that, you know, folks who are listening to this webinar that should really take into consideration, because that's a partner, you know, helping a manufacturer to come to the right solution. Maybe not the solution that's the most beneficial for the integrator, you know, that we don't get to sell a robot or whatever, but that we arrived at the right solution. And so that's a perfect example of the sort of thing that you should expect from an integrator.
Exactly. So we're going to touch on some on this slide, addressing some common automation myths. Debunking these myths are important from the start of a project as well. And when you're building your team, you kind of need to come to them with a mini scope of what you're going for. And you keep in mind that a lot of folks will have these myths and misconceptions in mind, that it'll just pop into their mind, that machines are going to replace people. Like if you're talking to operators, that's I'm sure a fear I've come across even in the water industry. That, you know, if I automate this, then I'd like my little drive out to the desert to look at the site to see what the water level is. I don't want to get rid of that. If we automate it and can see it at the City Hall dashboard, the SCADA's dashboard. So that can be the case there, where, you know, they have other opportunities there, and involving and addressing these myths right up front with leadership in their organization is important, because more often than not, if you're in a good company, your leadership is going to have a career path in mind for you that is a growth path, right? And so getting this all together and knowing, you know, kind of what the various levels of your are thinking there, and the team all on the same page, on these myths is important. Automation is going to fix all of your problems. That is, that is not going to happen per se. It's important to keep in mind some of the old gauge analysis stuff where you're looking at repeatability and reproducibility. It's also in science where you may have an experiment that's repeatable with the same person, the same environment, and all the conditions are the same. But then when you roll it out to be reproducible by other scientists or other, let's say, operators on a production process, that could change, right? So that's something to keep in mind, that if you have a solution in mind, you need to look at it from all the different aspects. And that's where engineering firms and manufacturing engineering help, like from Tech Help, can help make sure that all facets of a potential solution are looked at and considered. Automation is just robots. I referred to the precious metals and minerals mining outfit earlier. In that case, we didn't think that replicating their kind of half-baked robotic vector was going to be the solution. If anything, more suction cups to pick up more objects at one time, more ingots at one time would help. But it turned out that they basically crammed a lot of people into a little space alongside this cell. And what they needed was some vertical storage, and it was, a much simpler automation solution, and also sorting, so just some conveyor system changes and some vertical storage would have taken care of much of the constraint they were experiencing at that point in their process. So it's not only about robots. People love the robots. They love to get on a FANUC, like it's a Ford versus Dodge, and it's, it becomes a thing, right? So addressing this misconception up front is important. And it also is much less expensive, the solution that we talked about with them, rather than the robotic arm, because what they wanted was, what they wanted was a 3-bedroom bread and butter house. What we proposed to them was more like a 5-bedroom mansion, and really what they needed was more like a 2-bedroom apartment. So it doesn't have to be very expensive. And automation is only for big companies. I feel like that's a little redundant, only because of our experience, but that's a misconception that you might have, especially in small companies where it's just a few folks up to 50 folks. It's just not in the budget. We can't really look at that right now. So then addressing that has to do with the business case items that Chris referred to later, and I think that would help debunk that. Chris?
Yeah, and I think really, especially with the machines are taking our jobs issue, I think most people are pretty aware of the hiring, the job market these days. Of course, it's changing a little bit, but it's been a pretty tough go the last couple of years. And automation is they're taking jobs. They're taking the jobs that folks find undesirable, or that are perhaps not the safest in the long term, like stacking cases on a line. That's gonna over time, those repetitive movements are hard on the body, and so it's just simply better to have a machine do that job. And because it can be so difficult to find people, generally, even if a position is eliminated using a robot, for instance, I'm focusing on that example, but generally that person is just going to move to some other vacancy in the plant or get upskilled in some way, as Jonathan mentioned. So I've actually not seen many automation projects in recent years that have actually caused any layoffs. It's typically just movements of headcount, and it's a good idea to approach it that way.
Exactly. All right. So implementing scalable automation. This is something that Chris and I, probably more Chris than I, but I'm going to speak to it first, have really strong feelings for, because when we go into operations, I see a lot of different operations because I'm in business development. I don't get deep in the weeds, but I will look at what equipment they're using, what kind of PLCs, the computers and the control cabinets and so forth that is running the conveyor, and whether or not they're obsolete, whether or not they're coming from a well-known and tried true companies such as Rockwell Automation or Siemens, and those kinds of considerations are important, which we'll get to more later. Those kinds of things are important to, in so much as you thinking ahead, but keeping it simple, right? The standardization is helpful in so much that these top 5 suppliers of a particular type of PLC, for instance, or IO or controller, they have a roadmap ahead of them. And so if you standardize across the facility with that, with someone who has that roadmap ahead of them for obsolescence and can keep you informed and updated, that is key, right? And then leaving room for expansion or future projects. And that's not just the physical room. You may want to start small, pilot a change, but keeping in mind that you need, floor space, yes, but you also need room in the conduits and the control panels, in the PLC and the IO itself. You may want to have extra IO there available for, once the pilot moves on to, replication, let's say, you'll need to use some additional IO. So if you build the project initially and not considering what your growth plans are or what might happen down the road, then you end up having to redo it, and that's costly, right? And then as I touched on earlier, that repeatability and reproducibility is a key consideration. You want to try to simulate it also, with this. You can simulate it, a process change. Looking at this picture, this conveyor going down the line looks like a packaging process. And let's say you want to do a divert for more operators to do a packaging operation, labeling or whatnot. You can basically do, a role play. Someone pretends to be a robot and they take the package off over this other table. It's a pretend conveyor. You can do things inexpensively, but then you need to also test for the repeatability and reproducibility, right? Put in different operators and whatnot before you start spending a lot of money on the change with respect to capital expenses, so forth. So before that, you can also use simulation software. If you have someone with a little bit of time, most suppliers of automation products, such as robotic arms, such as PLCs, such as SCADA even, they will have either a trial or free software offering that you can work with and test the process change, on the software. That's something that to keep in mind. A lot of people won't have that kind of time, so to learn a software, but it doesn't necessarily take a lot of time either. If you have a few hours each week, you can have the vendor give you quick training, and you can and it makes for a much better presentation when you take your business case to all those in the team as well, I think. But those are some things to keep in mind as you're thinking about implementing a scalable automation. Chris?
Yeah, I think, everybody knows just how expensive things have gotten in recent years, especially. But the idea I'm about to share isn't necessarily new, though, is that the incremental cost of having a little bit of room when you're, in a control panel or conduit or something like that is very low. The amount of labor it takes to run a 3/4 inch conduit, for instance, is about the same as it is to run an inch or even an inch and a half for that matter. And so it's generally a lot better to just have that little extra space. I recognize, if you're in a startup situation or a small company that can feel painful spending that little bit extra money, but I promise you it'll pay you back, because running another conduit some couple of years later is going to be very expensive, and you're going to wish you'd have put just a slightly larger conduit in from the get-go, so you had some room to grow in the future. And the same thing with the hardware that you start with in a process, and I'll speak about this on the next slide, but you know, sticking to a big name control system in the beginning is a really good idea. I definitely recommend against, you know, PLCs that are bought from certain popular online controls distributors and things like that, because like for instance, we recently engaged in a project at a small hydroelectric power plant where there was a myriad of issues, but one of the biggest issues was that they had hired a controls firm some years back to install a PLC and an HMI, and they had only spec'd it out for precisely what was going to happen at that time. There was no room for expansion. In fact, the PLC does not, because it's it was purchased from a certain online distributor. It just doesn't play well with other systems. And so rather than just coming in when they wanted to add some automation in their plant and simply adding some code, adding another screen on their HMI, we ended up having to tear the whole thing out and start from scratch. Also because, and this kind of goes back to you know, that first slide of maintaining accountability and having clear expectations, is not only was it not really up to scratch as far as meeting future demands, but the integrator even locked the program in the HMI and the PLC. And then that integrator is no longer available. And so what do? Now you're left trying to reverse engineer this PLC, which we've had to do a fair bit of that, which isn't terribly fun, and it's pretty labor intensive. And so it's just, you can see kind of what I'm driving towards is that it's pretty expensive to rip things out and start new. It's pretty cheap to just add a little bit onto what you've got. And so it's very cost effective to think ahead a little bit, and recognizing that maybe, you know, cost constraints are very real for smaller companies and you can't add a ton, but add where you can. Okay, so standardizing and addressing obsolescence. So we kind of, the last conversation was a bit of a segue into this, but you know, you really got to think ahead when you're building these systems. You know, and a good integrator is going to be willing and able to have a good conversation with you about where in, you know, the life cycle a certain piece of hardware is, or certain software. Because I mean, I actually witnessed an integrator for a multi-million-dollar project install an obsolete piece of software in a plant just not that many years ago. And so you just really need to make sure that you're self-advocating and make sure you've got the right partner, so you get hardware and software that's going to go the distance for you. Because there's a couple things here. You know, it's very expensive to go back and redo things, as we just discussed. And then also there's this syndrome that sets in plants, and I call it the shiny penny syndrome, where you know, you have this new plant, everything's there's all these little blinky lights and everything's cool and everything's working great, everything's clean, and you get, you know, your staff and your operators, and they get kind of into this mode of, oh, this is a brand new plant. And then 5 years down the road, those same people are working there day in and day out, and it's just brand new plant, right? It's still brand new. It's only a few years old. What's the big deal? And all of a sudden, you've fallen into this trap of thinking that all of your stuff is still new, when actually it's not. And you start getting very close to the end of life cycle on some of the things that you installed when the plant was first built, or the process, or whatever it is that we're using an example here. But that becomes very expensive. And so building incremental replacements of things over, you know, say, because it's about 10 years. 10 years is about a good replacement cycle for controls hardware. Software, of course, is pretty upgradable, but even at that, there's some pretty major revisions that happen with software that require some extensive changes periodically. But you know, so if you install 10 VFDs, for instance, let's say you install 10 Yaskawa drives in a project, I would definitely talk to whoever's managing your capital plan or finance, or maybe it's you that's responsible for that. But put a note in your capital plan for 10 years out. Hey, or maybe a reminder in 7 years or something like that to start replacing those drives into a plan. So that way you don't approach this wall that happens of just all of this hardware that's obsolete, because now you're talking about so much capital that would have to go in to replace all of that plants generally, if a plant falls into that trap, now there's essentially this firefighting in perpetuity. And so for however long that plant's running, unless they get a huge infusion of capital, they're just going to kind of be replacing stuff as it breaks, because you fall behind and you just can't get caught up. And so I guess my advice is just really be careful about making sure that the hardware that you're choosing, the software you're choosing is up to date and it's consistent across your projects. And remember that it requires maintenance. And, because there are certain circumstances where it's very difficult to standardize. Like, for instance, let's say you use all Allen Bradley PLCs in your plant, but you've bought an OEM piece of equipment and they only provide Siemens controllers. That's okay, but just make sure to explore it. Make sure to ask the question. Sometimes for an upcharge, they'll provide Allen Bradley hardware. Sometimes it makes sense. Sometimes it doesn't. But just definitely have a conversation, definitely be thinking about that, because there's a lot of plants out there with outdated controls, and there's a lot of plants out there with 3 or more different types of processors running their plants, and it becomes really difficult to manage all of that, not only from a replacement and planning standpoint, but just from support, because now you have 3 different systems you have to train your folks to maintain, or perhaps even multiple integrators that will maintain those systems depending on what you've got. And so again, this all comes back to cost and simplicity in the long term. And as we all know in business, keeping costs down and keeping things simple is generally the best choice. And so definitely keep an eye on that from the very beginning.
Exactly.
Don?
I agree wholeheartedly, Chris. In fact, there's so many other places that change can come in from. For instance, the NFPA code 79 changed over a year ago that deals with fire safety and control panels, and people have had a year plus to update their control panels to meet these standards, and that's not happening. But your team is important. Either you have a team, 1.5, 2 people, can't really have 1.5 person, but in the facility, in your company that's addressing these ongoing obsolescence and standardization concerns. And that is, or you have, like Chris said, multiple integrators, engineers on part of the team, third parties that are going to help you do this and that understand what's going on with obsolescence. It's not just fire code, it's also security, software security. It's all over the news what's happening, shutting down airports and hospitals. And, this is something that's going to shut down your plant. Siemens, a few years back, their PLC, was shutting down semiconductor plants. So, it's something that you really need to have eyes on kind of regularly, as Chris was saying, and certainly don't think that, just because it's working, it's going to keep working past 10 years. That needs to be a much more, kind of periodic situation review of your system. Yep, that's all I got.
Yeah, well, thank you very much, Chris and Jonathan. We do have a few minutes for questions. You can either put it in the chat or you can just unmute and ask questions. We did get a question in the chat asking if anyone has dealt with fabric handling and positioning automation.
Sounds like labels. Closest thing I've come across is labels, and personally, I've dealt with a lot of equipment from overseas, from Italy, for instance, dealing with large sheet materials, for instance, or in packaging. Also in the packaging industry, there's large, there's wrap paper and whatnot, or shrink wrap material and that type of thing, that we have had experience with. Packaging tends to be more, inside the continental United States as far as the suppliers, the solutions. But, right here in Idaho, we have folks that are creating new solutions for those type of things. Fabric per se, I haven't had personal experience, but kind of the floppy material that needs to be, wound or whatnot, we've had experience with. It's something that I often go back to when go back to the manufacturer and ensure that they don't have someone boots on the ground in your area to address the issues, because they're the ones that are going to have technicians with their heads most in the weeds with respect to that particular piece of equipment and can address it. That said, there's a lot of very common equipment out there that most integrators can work with. What I caution against is, I guess basically looking at a control panel and thinking that any system integrator in your area is going to be able to deal with it. So you kind of do a little research up front and make sure that it's something you have, the serial numbers in hand, you have all that information so that the process goes quickly with respect to finding an engineer or system integrator that can handle the situation that you're looking at with respect to that equipment. Chris?
Similar, I mean, with material handling, because we do some work in the corrugate industry and with packaging. And so definitely have done work with handling, films and paper and things like that, indexing it for, material handling purposes or feeding packaging machines. So quite a bit of that, but not specific to fabric per se.
Anybody have any other questions?
Giannis, I got a question.
Okay, Luke.
Jonathan, Chris, great presentation. Thanks. And my question is for manufacturers that have a good idea of what they want to automate. They've got something that's classified as the 4Ds all in one. And they're trying to shop around with integrators. What's the baseline of information that is helpful to come to integrators with to understand like what the project may be? Like what kind of, when they approach you, like what are some key things that you would like to know about like maybe the process or the scope or things like that? Certainly.
I'll start off, Chris, if that's all right. Because I do a lot of this in business development, and I go out, if I go out to a facility, oftentimes with what's called an assessment form, right? And I do a quick consultation with them. I promise them they can either have a formal assessment written up from my findings, or it can be, it can be in the form of a proposal. The assessment's included as a scope of work in the proposal. But what I will generally ask for with respect to system integration is things like what is your communications? How's that? What's the IT? What's the network architecture? What PLCs? Anything connected to what we're talking about? What PLCs are connected? How much I/O? How much of it is discrete versus analog? And I'll just go down through a list of questions along those lines. And oftentimes I'll do this with plan room stuff, which I call their plan rooms that engineering firms, civil engineering firms, and so forth will put out there publicly. So a good place to look at for future research on this topic, Luke, is because they're public, you can go to these plan rooms. Oftentimes they're public. You can go to these plan rooms and get like a set of plans and specs for a water system upgrade, right? And there'll be sections in that spec, for instance, division 45 in the specification, and there'll be also on the plans, the drawings, there'll be I/O and electrical system pages. You can go there and kind of see what we're going to be asking for as far as, what we need to look at, the connections, be it, telemetry, network, I/O that's monitoring or controlling monitoring instruments or controlling motors, putting that all together to basically frame the problem or basically frame what the situation is, and then we can come up with a solution, and we'll kind of bring back our solution with those types of details to you and walk you through our thinking on those types of things, on all that information as far as the proposed solution. And from there, the discussion continue.
Yeah, I agree. And I think, Because we definitely don't expect everyone to be controlled systems experts and know precisely what to ask for. And I think in the absence of knowing what's required, I think just simply reaching out and asking first would be a good path, and then perhaps an integrator has an information collection form. We have one as well. But also a good integrator is going to be willing to help with that. But I would say that kind of going back to one of the early slides, at a minimum, if let's say, you know very little about controls, you don't know a ton about this stuff, at a minimum, have a very clear problem statement. What is it precisely that you're looking to solve? What are the conditions that you have in the plant right now? Because if you can approach that clearly and have a good conversation about that, generally an integrator is going to be able to dig in and figure out the rest pretty quickly. It's when you approach an outfit with, well, kind of these are some things we're thinking about, or it's very unclear. That's when things can start to get squirrely and a lot of time can get wasted. So just I would definitely recommend always having a clear problem statement to the best of your ability, at a minimum. And then, like I said, perhaps, if there's an information form or certain things you can get from an integrator, that'd be a good step as well.
I agree, Chris. And another thought came to mind is with respect to Tech Help and all their offerings. I think their second slide on this presentation has a graphic with all their offerings. They can do so much, if you don't have a manufacturing engineer yourself at the facility, to go through and do a process flow diagram of this current situation and kind of lay that, what the situation is out, so that problem statement can kind of gain a lot of clarity and solve many meetings and investigative type meetings down the road.
Appreciate the feedback, guys. Thank you.
So we are out of time. We want to thank our guest speakers for joining us today. Appreciate your time. Keep in mind this is recorded, so we will provide the recording to everybody and throw it up on our webpage so you can see it as well. Thank you everybody who took time off to visit with us or is watching the recording. If anyone has any other questions you didn't get to ask, if you have some projects you're kind of thinking about wanting to do, if you have some potential things that you would like to look at, just let us know. We'll be happy to vet it out with you and have a chat about it and then figure out what resource would be the best. So appreciate everyone. Thank you again, speakers. You were awesome and you gave us a lot of great information in this tiny little condensed time. But appreciate everybody and hope you have a great rest of your day.
Thank you.
Thanks.